So I wanted to talk to you about metallic bonding. The purpose of this lecture is to describe the metallic bonding and explain metallic properties such as thermal, electrical conductivity, malleability, and ductility. What you will learn through this PowerPoint is to define metallic bonding, identify properties of metallic bonding, and define alloys. So metallic bonding occurs when there are metal atoms organized together in a crystalline structure. With those atoms, there are delocalized valence electrons that are freely flowing around, as you can see on the picture to the right. So those free-flowing electrons allow the metallic bonding to have certain properties. At the bottom, you see that metallic bonding also is organized in a crystalline structure similar to that of ionic bonding, but these are only metal cations. And the electron is what is decreasing the repulsion among these metal cations. The basic properties of metallic bonding is that they're crystalline in structure. They are different types of crystals in regards to ionic crystals, so make sure that you keep that in mind and try to figure out what those differences are. Metals have different crystalline shapes. It all depends on the metal and on how it is arranged. So to the right, you can see that these are three basic types of crystalline shapes: simple cubic, body-centered cubic, and face-centered cubic. Metals also have the ability to conduct electricity through the flow of electrons. They are lustrous because they can absorb and emit light. They're also very ductile and malleable, which means they don't break easily. So think about foil paper at your house. Think about copper wiring. Metals are very well to be shaped, and it's because of those free-flowing electrons that reduce the electrostatic repulsion between the metal cations. So it's opposite from being brittle. Here are some images of crystalline structures for different types of metals. You have chromium is body-centered. You have gold as face-centered. And then you have zinc, which is a different shape, hexagonal close packed. So as you can see, the more complicated the structure gets, the less space there is between the metal cations. And that space also affects how it's going to be able to be shaped and formed, and the different properties, how all that's going to be affected. Here you can see a quick image on how these metal cations behave under different circumstances. So letter A just represents how electrons are free flowing throughout these metal cations. B represents how electrons can be organized and follow the direction of electricity so that they can conduct electricity. So on B, on the left side, you see negative, on the right side, you see positive. And so the electrons are going to line up towards electroconductivity to allow it to flow. Metallic bonding also allows for a good heat to be conducted. So these metal atoms, they're solid in their state and they will vibrate. And so as they vibrate, they're able to transfer heat throughout that metal solid. D represents how these cations can be pulled so they can be shaped. At the very bottom, there's a link that also provides you with more information as well as videos on how metallic bonds behave. Let's move on to metal alloys. Metal alloys are mixtures of metals. And so these mixtures are made by melting different metals together. And these metals are going to come together in different types of alloys. So you have substitutional alloys and interstitial alloys. So in a substitutional alloy, metal atoms are substituted by other metal atoms, and that affects the way that that metal alloy is going to behave. Interstitial alloy just means that smaller atoms are going to take up the empty spaces found within the bigger metallic compound. And at the top right, you can see a video of how this would be a memory shape alloy. And so at different temperatures, it'll go back to its normal shape. So if any of you have braces, that's one example of a alloy that's in your mouth. Alloys enhance metallic properties. So alloys are very important in our everyday life. Here are some examples. Brass is a copper zinc alloy. Bronze is a copper tin alloy. Steel is an iron carbon alloy. And then sterling silver is a silver copper alloy. And in all these, the metals have actually been enhanced and strengthened through the combination with different metals.